For the OGC 3D data container and tiles pilot, Ecere provided client and server components based on its GNOSIS geospatial software products. The initiative explored the delivery of 3D content within the framework of the new OGC API family of standards. 3D data and its Web API access mechanisms can be discovered based on reusable building blocks of the upcoming OGC API common standards. The data we used in this experiment originated from the sampled CDB dataset of Camp Pendleton. In one approach, we experimented with the Tiles API, streaming multi-resolution tiles of imagery, terrain elevation, as well as vector data tiles containing points referencing 3D models with position and orientation information. These tiles follow a regular tiling scheme based on the 2D tile matrix set standard, in this case based on a geographic coordinate reference system. Our compact E3D format was used to transfer the models to the client, but support for serving the models as GLTF was also implemented. As trees for this dataset are defined as geotypical, with only few models reused at thousands of locations, they are rendered with a single drawing call using model instantiation techniques. We also implemented support for the OGC 3D Tiles community standard in our latest GNOSIS visualization client and tested these capabilities by performing technology integration experiments with services from other participants of the pilot. This particular 3D buildings dataset of Manhattan and New York City was being served by all of these services. 3D tiles are organized in a bounding volume hierarchy, allowing to quickly cull out large portions of the data out of view and progressively refine the content as the viewer gets closer. 3D tiles also does not require the use of a set tiling scheme, as data can be organized arbitrarily based on its density distribution. The imagery shown here is still being retrieved separately as regular tiles. This textured dataset of Berlin originated from CityGML and is also being served as 3D tiles by Virtual City Map from Virtual City Systems. This service was not one of those provided by participants of the pilot, but offered an opportunity to test our client with very large and detailed data. This very detailed dataset of the Warrata railway station in New South Wales, Australia, is being streamed as I3S from the NSW Spatial Data Portal and cataloged by the Cesium service. An external conversion API from Teria.io is used to convert the I3S data to 3D tiles for consumption by our client. Bounding volume hierarchies enable the use of arbitrarily detailed 3D models such as building information models like this one. This dataset of Montreal originated from CityGML and is being served as I3S from the service provided by Helix. The Teria.io conversion API is also used to convert the I3S data to 3D tiles for consumption by our client. This dataset of Marseille is also being served as 3D tiles from the service provided by Skymantics. Our GNOSIS engine tessellates a 3D mesh of the terrain on the fly from the elevation gridded coverage tiles. The Tiles API could also easily be extended with vertical subdivision to support highly detailed multi-stories buildings, organizing the data in a geographic space octree. These 3D buildings of West Sydney are being served as 3D tiles from the service provided by Cesium. This worldwide buildings dataset originates from OpenStreetMap building footprints and associated attributions. It is being served as 3D tiles from the service provided by Cesium. In summary, the pilot allowed to prototype and experiment with the integration of multiple ways to deliver and access 3D data, such as the Tiles API, as well as the 3D Tiles and i3s community standards within OGC API services and clients.